Let's talk about the superposition principle. Now, diodes and transistors are nonlinear, but when driven by a small AC signal, they operate over a linear part of their IV characteristic. So we can use superposition principle or theorem. It's not obvious why it works, but it does, and we use it. Now, what we want to do first is we want to find our DC current through the diode. So there's a capacitor here, so no DC is going to flow this way, so this is our equivalent DC circuit here. We got 10 volts, 10K resistor. If we divide that out, we get 1 milliamp of current going through here. Now, there is some resistance here. It's called bulk resistance. It's the bulk resistance of the diode. It's a resistance of the PM junction. It's a change in voltage over the change in current. Now, one way to calculate that is to look at our data sheet here. And we're going to pick this here. We're going to pick a volt. And we want to pick it over the knee voltage there and get into the more linear region of the diode. So we take our 1 volt here and run this up this line here. This is our instantaneous forward voltage and instantaneous forward current. Up here, this is 100. This is a logarithmic scale. This is going to be 200. So at 1 volt, we're going to have instantaneous forward current of 200 milliamps. So we take this voltage, this change in voltage. Now, we're going to have to subtract the knee voltage, our 0.7 volts. So it leaves us with 0.3 volts, and we divide that by our 200 milliamps, okay? That gives us 1.5 ohms, okay? Now, 10K is orders of magnitude greater than that, so we can forget about that in our DC analysis here. Let's take a look at the AC. Now, here's our AC circuit here. We take our DC feed point here, and we ground that, we short that out here. So our circuit's going to look like this over here. We're figuring this is just a perfect capacitor here. Now, we have to find the AC resistance of the diode here, okay? This is going to be our diode here. Now, the dynamic resistance of the diode, it's the voltage is usually about 25 millivolts. And you'll see that in a lot of diode formulas. So what we want to do is we want to take our 25 millivolts and we divide that by our current, which is 1 milliamp. And so it comes out to 25 ohms, okay? So the AC is going to see 25 ohms. Now, the resistance, AC resistance, is going to be our junction resistance plus our RB over here, our bulk resistance, which is 1.5. So it's going to be 26.5 ohms. And that's what the AC is going to see there. So we just take our 26.5 ohms and we divide that into 1 millivolt, and that's going to be 0.037 milliamps or 37 microamps. Now, we just add the two together. Here's our 0 here. We have 1 milliamp coming up this way, and then we have our sine wave on top of that with a peak of 37 microamps on that. So that's our total current through the diode, and that's using the superposition principle. So that's it. Thank you.